Hi. Today, what we are going to see is about going to see the problem which is 2 sum 2 where the given input array is sorted. So, why this problem I am going to say is that we are now going to solve 2 sum, 3 sum as well as 4 sum. 2 sum 2 first I am going to solve. After that 2 sum 1 we will solve. So, what the problem statement gives us that we need to find the sum of two elements where the sum of two elements is results in getting the particular target which they have been given. Okay. So by seeing this problem, what the brute force solution you can think. So what the brute force solution you will think, like you will get this number 2. After that getting this number 2, we need to add with 7, we need to add with 11, we need to add with 15. Like that the brute force approach will be get into our brain. So what the optimal approach is that we need to use two pointer. So why we are using the two pointer is that the question is given like that the given input array is sorted. So whenever the given input array is sorted means at that particular moment we can use the two pointer approach to get a optimal solution. So how we can implement a two pointer approach in this problem is that the question is simply asking we need to sum the two numbers and we need to get a target. So I explain with this example only. Consider this is the example, right? I'm placing one pointer which is left pointer. So what this left pointer points is that the left pointer is pointing to the minimum element. So the question is already said the given array is sorted. So what the left pointer will does, the left pointer will points to the minimum element which is present in the array. And the right pointer will point to the maximum element which is present in the array. So where the maximum element will be there, the maximum element will be at the last of the array. So because it follows the sorted order property. So now what we can do is that we just need to add these two numbers. So adding these two numbers results in what? 2 plus 15. 2 plus 15 results in 17, right? So 2 plus 15 results in 17 means the 17 we need to compare with the our target. So after comparing the 17 with the target, we can say is that the 17 is greater than our target. So what interpretation you can say is that I'm having a sum which is greater than my target. So which is greater than my target means I'm having a maximum element which is more maximum than what I needed. Which is more maximum than what I needed. So what I can do is that I can move my right pointer to just before one element. One minute. Move this right pointer to front. So after moving this right pointer, we can say that my sum of two elements will be decreased. So how the sum of two elements will be decreased? Because the right pointer pointing to the next maximum. Next maximum means after omitting this 15, the next maximum is 11, right? So we are going to see the addition of 2 plus 11. So what is 2 plus 11? Which is 13. The 13 also greater than our target, right? So if we encounter a sum which is greater than our target means we need to move our right pointer to front, to before element. We need to move the right pointer to the before element. If we are encountering a sum which is greater than our target means what we will do? We need to maximize our sum because our sum is less than the target. So for example, if I'm having here, if I'm having here 2 and 2 means I'm not getting the sum, right? So I need to move my left pointer to the front. So in such a way that I can get the required sum. So the logic is simple. The left, so the algorithm is like step one, left points to the left points to first element, which is the minimum in the array. Step 2, right pointer points to last element, which is the maximum in the array. So I am saving which is maximum, which is minimum, means it follows the sorted order behavior. Step 3, here we are using the if condition to check if sum is greater than our target, means what we need to do, we need to, sum is greater than means we need to reduce the sum. So we need to reduce the sum means we need to reduce the maximum element. So we need to reduce the maximum element means the maximum element is pointed by right pointer, right? So we need to reduce the right pointer. Else, if the sum is less than our target, means what we need to do, we need to increment our sum. We need to increment the sum means we need to increment the minimum element to the next position, so that we will increment our sum also. So we need to increment the left pointer. Another case is that if I'm having sum equal to target, means I just return the two values. That's all. So we can code this. Left pointer points to the zeroth element and the right pointer points to the, we change this to nums, and the right pointer points to the last element. Perfect. So when the condition is stops, so when will be the condition or when will be the checking will be stop is that whenever the left is less than right, means I can do addition of two elements. When the left is less than right means I can do the addition of same elements. If left and right points to the same elements means I will not perform addition. Like if left is equal to right means I will not perform the sum operation, because both the element will point to the same, because both the pointers will point to the same element, right? At that particular moment I will not perform any uh, calculations. So when the condition is going to get false, so the false condition is that when when my left pointer is crosses the right pointer, when left crosses the right pointer, or when left is equal to right pointer, means this is a false condition. This is false. In that false moment I need to break my loop. So which is the true condition? I need to perform the operations till my left is less than right, which is the true condition. So after finding the false condition as well as true condition, we can code. So while left less than right, I can perform operations. Then int sum is equal to nums of left plus nums of right. So in here, I need to determine how my pointer is going to move. If the sum is greater than the target, means the pointer is moved, the right pointer is need to move to the front. Else, if the sum is less than the target, means what we need to do? The left pointer moves to the front. Else, we found the sum which is equal to the target. So whenever we found the sum which is equal to the target, what we need to do? We need to return. So just return this by the element which is present at the left index, also the element which is present at the right index, and we return. If we didn't found any sum which is equal to the target, means what I can return? I just return -1 and -1. That's all. Okay, there is a error. So we need to give the index values. Also the index values need to be one based indexing. So what I does is that I need to give here index values left plus 1. The why I am giving plus 1 is that it is in the question they have given said that, see, which is one based indexing here. Need to give left plus 1 as well as right plus 1. 1 less than or equal to index less than or equal to index 2 less than or equal to num start length. This is a untest index. So after we have completed this problem, what we can do? We can do try to solve the tree sum problem. So we have completed the two sum problem. Now, if we completed the two sum problem, means the three sum problem will be very easy.